Good afternoon, kiddos. It's me, Mrs. Red again, here to give you some help with your math homework for tonight. And this homework is using what you get about information. You're going to be using a part and a percent to find the total number. And in class today, we looked at, when you're looking at problems like this, whenever you read a problem, like in this one right here, it says 13 is 20% of what number? That of what number means that we have a missing total. We don't know what the whole amount is. We only know a part. And for this problem, the part that we know is 13. So let's take a look and see what this problem looks like when we solve it with a model. Now, when it comes to your models, it really doesn't matter if you use the double, like the tape diagram, or if you use a number line. It really doesn't matter. Your brain likes one more than your brain likes the other. I'm going to show both, but you can just pick the one that you like the most and use that one. So here, if I'm looking to see that 13 is 20%, I know that percents of anything go from 0 to 100. I also know that 0% of any number is 0. What I don't know is what 100% is, because where it says of what number, that's the piece that's missing. Okay, so we know we have this missing piece right here, but now what I need to figure out is what size pieces to cut these into. And you're going to notice here I'm looking for 20%. So what I think is a good idea to do is to look back at this chart. If you don't know that off the top of your head, look back at this chart and look for the biggest piece that you can use to land on 20%. Obviously, that's too big. 25 is a little bit too big. But here are my 20s. And there are 1, 2, 3, 4, 5 of them. So I need to cut my model. Either model that I use, I need to cut into 5 pieces. 1, 2, 3, 4, and 5. If you prefer the tape diagram, or 1, 2, 3, 4, and there's my 5 right there at the end. Either way, if you're doing the number line, you're going to count by 20s. 20, 40, 60, 80%, and there's our 100. If you're using the tape diagram, each one of these little sections holds 20% of the total. Now the problem tells me that 13 is 20% of something. So if you're using the number line, we're going to have 13 right there. And every time we go up, we're going to add 13 more. So 13 plus 13 is 26. 13 more is 39. 13 more is 52. 13 more is 65. So there's my total. There's my whole. We should get the same answer, though, even if we go here, because it tells me that 13 is 20% of this. So that means this little piece right here, that's 13. And every single 20% piece is 13. So here we had 5 13s. We knew what this 20% piece was, and we used that information to build the rest of the model. And when we solve it that way, we still get 65. But let's look at the same number with a proportion. Remember that percent over 100 equals part over total. And for this problem, we have 20 over 100 equals 13 over something. Okay. Well, if I look here at my proportion, it's not easy for me to tell what I did to 20 to make it a 13. I can't tell what I divided by. When I look right here between 20 and 100, I notice that that's a 1:5 ratio. But I'm going to solve it this way. I'm just going to scale. 20 to 100 is 13 over something. Now, I can look at 20 and 13, and I know that there's not very many numbers that play nicely with them because 13 is prime. The only number I can use right here is 1. So to go from 20 to 1, I divide it by 20. I need to do the same thing to 100. And when I divide 100 by 20, I get 5. Now I'm going to scale up. To go from 1 to 13, I multiplied by 13. And if I multiply 5 by 13, I'm going to get 65 again. Now, when I said that this was a 1:5 ratio, look right here where we simplified this. Our simplified ratio is 1:5, which really means we can take this number at the top, multiply it by 5 to get to the number at the bottom. 20 times 5 is 100. 1 times 5 is 5. 13 times 5 is 65. You can see that pattern in their relationship. But look at the other thing I want to show you. Right here on your model, look. This is 1/5 of your model. And if we do the same thing, if we look at the same thing right here, this is 1/5 of your model, which also represents a 1:5 relationship. I'm just showing you that, just so you kind of see it when you're looking to solve math problems with proportions. You can look for relationships that go in all kinds of different directions. Okay, let's take a look together at number 2. Number 2 says 22 is 40% of what number? Okay, well, I'm going to solve this first with the model. Again, you do not need to use both. I'm just showing both because I know for some of you, you prefer the number line. And I know others of you prefer the tape diagram. So here, because we have this of what number, we know we're looking for that missing total. Whichever model I use, I'm going to show percents from 0 to 100. And then my total is going to be blank because that's what I need to solve. So if I'm looking to find 40%, I want to use as big of a piece as possible that I can cut this into to land on 40. So again, looking back here, if you can't think of it off the top of your head, go back to your resource. 25s are too big because 25, 50, 75, I skip right over 40. But look here, 20, 40, 60, 80, 1. Here I land on my 40. So I'm going to cut this into 5 pieces so each piece can hold 20%. So let me go down here. 1, 2, 3, 4, 5. Each one of these boxes represents 20% of the total. Sorry about that, kiddos. So we were saying 20, 40, 60, 80. There's another 20. See, each piece holds 20% of the total. And down here, if I want to cut this into 20% pieces, there's 20, 40, 60, 80. My 100% is already at the end. And there's my 100. Now, here's what I know about this problem, and this one is a little bit different. This problem tells me that 22 is 40% of what number? So if you're using the number line, your 22 goes under your 40%. And you can use this information to solve the rest of it. If you're using the tape diagram, we know that 22 is 40% of the number. That means this piece right here is 22. Well, if this piece is 22, we need to share that 22 between each one of those boxes. And 22 divided by 2 will give us 11. So each one of those 20% pieces is 11. And 11 times 5 is 55. We're going to get the same answer when we solve it down here with a number line, because we knew that 22 was 40% of a number. So here we had to go 2 jumps to go from 0 to 22. 22 divided by 2 is 11, which means you're skip counting by 11s. So we have 11, 22, 33, 44, and last but not least, there's our 55. So both models show us that we get 55 for our answer. Let's do the same thing with the proportion. Percent over 100 is part over total. And for this problem, 40 over 100 equals 22 over something. Now, I know you know the answer is 55, but let's pretend we hadn't done the model. Let's say we started with the proportion. We could set this up like this. Because really, it's not very easy to tell what I did to 40 to make it a 22. So I need to find a common factor, a number that's going to play nicely with both of these. And for 40 and 22, I'm going to use a 2. To go from 40 to 2, we had to divide by 20, which means we need to do the same thing down here to our 100. And 100 divided by 20 is 5. Well, now we're going to jump up from 2 to 22. 2 times 11 will give us 22. So if we multiply 5 by 11, we get 55. So all 3 ways that you solve that problem, you got 55. Now let's take a look at the questions that you had on the back. And let's start here with this first one. 36 is 30% of what number? And I'm going to come over here and I'm going to solve that with a proportion first. Percent over 100 equals part over total. And for this problem, that is 30 over 100 is 36 over something. It's not really very easy for us to tell what we multiplied 30 by to make it a 36. So I'm going to go down here and I'm going to scale my ratio. But when I scale my ratio, I'm going to try to get my fraction reduced right here. Let me show you what I mean. 30 over 100 is something over 30. There is 36 over something. And I'm going to try to get my ratio simplified right here, because that can help you with your model. 30 and 36 have a few common factors. I could use a 6. If this number was a 6, I would divide by 5. 100 divided by 5 would give me 20. But 6 over 20 can be reduced. So instead of a 6, I'm going to use a 3. To go from 30 to 3, I divided by 10. So I'm going to do the same thing to 100. 100 divided by 10 is 10. This simplified ratio right here can help you because the denominator tells you how many pieces to cut your model into. So for you to model this, you're going to need 10 pieces. Now I'm just going to scale up. To go from 3 to 36, I multiplied by 12. So I need to do the same thing at the bottom, and 10 times 12 is 120. I'll take a picture and post it so you can see the models. See you tomorrow, kiddos. We're just about out of time.